Okay, so we understood what is data visualization. We further understood in the previous lecture that why data storytelling is more important, right? And how data storytelling works. Fine. Now the idea is after data storytelling, the next part of data analytics is where you store the data. Okay, where the data is being stored, how companies store lot amount of data. Okay, so therefore there is something known as data warehouse. Okay, so this data warehouse is usually being covered in lot of computer science engineering courses, right? In many CSC engineering BTech MTech people, you will be seeing that they must be knowing a lot about data warehouse, but many in data analytics courses data warehouse concepts are not covered. Okay, here in fact you will see in other departments it might not be covered. Okay, even you can see any other courses apart from this, data warehouse is not given that much importance in data analytics, whereas data without data warehouse you cannot understand the pipeline. Okay, even though it is theoretical, it holds lot of values. I mean, it will give you an idea what is happening. Okay, means like how data is flowing in the pipeline. Okay, after visualization what happens, how you store data, how each of these steps go hand in hand, right? So therefore we need to understand data warehouse. Now how to handle big data, right? How to handle, there is something known as data mart, data lake. What's the difference between them? So whenever you want to do any internship, any project in data analytics, real world project, I mean like you get data from different sources, different companies, and you work on those data sets. You do exploratory data analysis, that is you clean the data, right? You create a data set, then you find what are the features of the data set. Does it need any PCA feature reduction, right? Then you try to plot them, data visualization. Which plot is good? Bubble plot, bubble chart, line plots, histogram, which is good? Pie charts, right? After that, you storytell, right? But most importantly, you should have a system where you can store your data, and the system which can have not only storage capabilities. You will see, then why not we use a hard drive? Why not we use a hard drive, right? Hard drive also stores data, but data warehouse is more than just a hard drive or data storage system. Okay, data warehouse has this BI tools, okay, intelligence tools. Okay, it can use extra tools to understand your data and do some further analytical processing. Okay, further processing can be done in data warehouse. Okay, so in that case, data warehouse stands out from just a simple data storage system. In this remaining part of the course, we will also understand how data warehouse, okay, how data warehouse stores the data. There are two different types of approach. One is Kimball's approach. There is something different schemas also. How different companies or sub companies or different departments of a company store data. Okay, that is like we will see stars, star schema, and another is snowflake schema, right? So star and snowflake schemas are very much important for anyone who is studying data analytics. Okay, they should know about these schemas, right? Uh, this is how these topics stand out from just statistics. Okay, these topics, when you understand data warehouse and all, these topics stand out from just a normal course from statistics, right? So we will see in this course how IBM is using its data warehouse to store data and do data processing. So IBM usually use DB2 warehouse. Okay, how other companies are using their how Oracle is using, right? How other companies are using their data warehouse, right? We'll see one by one. Now there are different kinds of warehouse. Okay, what are the kinds of warehouse? There can be a warehouse which is physically available. Okay, like a system or a server which is physically available. For example, if you want to run a piece of code which is heavy, I mean you have to run maybe 10 to the power 6 number of runs or elements you have to pass through. So if you do for I equal to 1 to, for I equals to 1 to for I equals to 1 to 10 to the power 6, then it might be trouble. Okay. So in place, what you are supposed to do, you are supposed to parallelize. Okay, you are supposed to parallelize the code, right? So if you parallelize the code, there are two options. Okay, how to parallelize the code? So I hope I had given you one idea that suppose this is a x variable, this is y variable, or maybe you can say temperature, and this is humidity. Okay, and you are color coding based on the temperature and color coding. You are color coding blue if it rained with that parameter, right? Is it fine? If I put a blue dot here, what happens? It rained. I mean, with that temperature and that humidity, it has rained. Now, if I put a red dot, it means it is high temperature. Okay, it means it is high temperature, right? If I put some other scale, maybe anything else you want to suggest? Snowfall, fog. Ah, okay. If orange, it is fog, right? If this one, it is snowfall, right? I mean, okay, possible. Okay, not here, but anywhere else it is possible, right? So you will see that this chart will be color coded and having these four colors, right? Do you agree? It will be a color coded picture with these four figures, right? Fine. I don't know if I have that here, but you can see something like this. Okay. This is not your syllabus, but just an example where you have a heat map, where you just have a heat map, right? I mean, this heat map, if you don't parallelize, okay, if you don't parallelize, it will take you almost 3 days to run, almost 3 days to run to make this code available, right? To make this plot actually. Why it is so difficult? Because of the resolution. We are doing 1000 cross 1000 grid, right? 1000 cross 1000 grid. So how many points are there? 10 to the power 6 points, isn't it? 1000 cross 1000, 10 to the power 6 points. Even if each takes 1 minute, each point to color code takes 1 minute. How many program time we need? Computational time 10 to the power 6 into 1 minute. That is 10 to the power 6 minutes. Now 10 to the power 6 minutes is how many hours? Yeah, you can use your calculators. I just want to give you a feel of parallel processing. Okay. So 10 to the power 6 minutes divided by 60 will tell you the hours. Okay. Fine. So how many hours? That many hours, if you divide by 24, that will tell you how many days. Is the minutes. 60,000 days. 664 days. 694 days. Yeah. 694 minutes. So 694 days. Okay. 694 days if each of your point takes 1 minute to run. Okay. 694 days means almost 2 years. Okay. Almost 2 years. So how are we going to achieve this? I mean, your program is very fast actually. Each point is taking just 1 minute to run, and you just want to generate a heat map, right? So it will take 2 years to complete this plot. So how are we going to handle this? So the yeah. So the idea is you can parallelize. You can parallelize. I mean, divide this area, this rectangular area into grids. Okay, grids. You see these grids drawn here. Okay, these are the grids, right? Fine. You understand what we are doing here? You divide the x-axis into grids, into fine intervals. Divide the y-axis into fine intervals, right? Then what will happen? Each point, each slice, suppose this is the slice, each of this slice, this is a slice, right? This will be another slice, right? This will be another slice. This will be another slice. Fine. Each slice you give to a single computer. Each slice you give to a single computer, right? So if suppose you have 1000 slices on the x-axis, so you give different 1000 slices to 1000 different computers and run at the same time, right? Each slice will take, each slice will take how much time? Hardly few days, suppose. Okay, fine. So this program will be computed within few days.